Good morning, everyone. This is the first time that I'm speaking in front of a talented group like this. Probably you'll figure out by end of this session. Today, let me start with a question. And please think about an answer before we jump into the slide number 3, because we have an answer in slide number 3. The question for the room today is cabin lighting now a safety critical system? Some might say yes, some might say no, and some might say it's just an ambient feature or just a background. For the next 10-15 minutes, let us discuss about this and then we'll come to common understanding. Before we jump into the technical details, let us have a look at complaints picture. Why we should link to complaints now? Because the complaints clock is already live. It's no more a future. If you see, China come there first. As of May 2023, there are about 3.3 million vehicles are installed with DMS systems, and which is expected to grow about 30% year on year. It is rolled out. It's rolled out in Europe in 2 phases. Phase 1, which is DDAW, which is mandatory, and perhaps it was based on the steering wheel angle and the lane-based systems. It's not a camera-based. And as of phase 2, whereas DDAW and ADDW was mandated, and the system need to function based on the camera-based systems, based on the eye and head tracking. Coming to the Euro NCAP, now in order to get the 5-star rating for the vehicles, continuous eye and head tracking is mandatory. To look into some numbers going forward, it is projected to be about $8 billion market by 2033. And also we expected annual compounded growth rate of 11.7%. All these regulations and all these numbers, which is of $8 billion market, is totally dependent on one thing: a camera that can see human face or driver face all the time. Yes. So as we see in the slide here, the answer is yes. Now in-cabin lighting is now a safety critical system. Let us start with some basic sensors, how the systems works. There is an NIR emitter which floods the cabin with 850 and 940 nanometer wavelength light, which hits the driver face or the occupant, who is in the car. It reflects, and there is a silicon sensor which captures the reflection. That is what your head tracking, and that is what is driver's gaze. And eye tracking, that's what which detects the eye blinking too. Here the critical part is the narrow window of 0.5 to 2.5 milliwatt per centimeter square energy that hits the driver face or the occupants. Why is that critical window? Less than 0.5, it's a blurry image. That's what our silicon sensor sees. More than that, it is a washed out image. That is a very critical narrow window. And as per the sensors, as per the NIR emitters, the industry is, there is a preference for 940 nanometer wavelength sensors. That is because it has a better solar rejection ratio, and it is fully invisible to human eye. Imagine, so all these, when this tighter window, which is of 0.5 to 2.5 nanowatt of centimeters per square, and imagine that within the car, for every 10 seconds, the environments keep changing. When you are driving, there is every possibility that window will change for every 10 seconds, maybe less than that. Now let us look into some of the common failure modes, what these sensors can face. One is an underexposure, as we all see here. The first one is underexposure. What it means and how it impacts the system. Underexposure is a common problem when we are driving through the tunnel, or it can happen a tall driver sitting a little far from the sensor. These things can happen. And when this happens, your pupil tracking fails. And when this happens, the blink detection fails. The second failure case is overexposure. This is very important, and I want you to remember remember this scenario when you are driving towards westbound today evening back home. When there is a flood of sunlight on the driver face, there where the sensor fails. It's not about the sensor; it's the regulations also fails. And the third failure is non-uniform light on the driver face. Assume that there are first two cases are good because we are not traveling towards westbound, or we are not traveling through the tunnels. But still there are some obstacles. What you can see is that a golf player hat brim can cause a system to failure. And at the same time, which is a normal condition, if the driver is looking at the side mirrors, there where your blink tracking can fail. And imagine all these three scenarios can happen in a single commute. These are not the corner cases. These are the regular scenarios where all these things, three can happen in a single commute. Along with this, next we can see how the cabin geometry or cabin material is going to impact the systems, how each sensor is going to fail, and what are the obstacles here. As we can see here, the cabin is an optical obstacle course. Why this is? This is because cabin was never designed for a DMS sensor. It was never designed for DMS sensors. And moreover, there is a gap where the cabin designers don't have the direct interaction with the perception engineers. Yeah, I'm not going to walk through all the entire complete list here, but we have listed few of the cases where the cabin material can impact the NIR behavior and how the entire system will be impacted by these cabin materials. If you see the matte or glassy trim finish in the car, you see there is a stronger reflection of NIR, whereas your silicon sensor may trigger the false positives. As you can see, another case, it's a seat recliner or posture. As we see the tall driver sitting back, so it can change the reflection geometry in the car. Due to this, the system can have the unstable tracking. So how do we address this? However, there is the sensor fusion we see as a common solution, or this addresses some of the corner cases or some of the use cases which are surfaced by InCabin cabin material. Yeah, here no single sensor wins alone. There is a combination. There is a combination of RGB, NIR, or radar, and time of flight sensors. Each sensor has its own advantages, and the industry headed towards the sensor fusion. Let's not go to the list of each and every sensor and what is advantage, strengths, and weaknesses. I have listed few here. There could be many. Now what? So we have the fusion sensors, which addresses the in-cabin material and the corner cases of day-to-day scenarios. These are the few silicons which are already available in the market. Note, I'm not working with any of these, but I'm not marketing for this too. But I just some Google search gave me the sensors here. This addresses some of the corner cases, what we are facing, what industry is facing, what DMS sensor face today. And this is the few of them, and some of them are already in production. Some of them may be available in future, maybe by end of 2026. As we see, we have the hardware is also ready. Now, what is the next thing? Yes, building it is easy. Always building a system is easy, but the harder part and tough part here is making sure or proving that the system works. There are so many corner cases. Here one see, if I see the lab environment or our testing lab may not cover all the sun angles which can happen at the real time, or it cannot include all the seasons and all the simulation, all the things that can happen. And we cannot simulate our sensor for all cabin materials and all seat positions. So what we see is, with respect to the AI, in terms of technology available in these days, AI, synthetic data is a one solution, one lab solution which could address all the corner cases where one can generate a synthetic data by which we can we can cover all the sun angles or all the seasons, or we can simulate all the cabin material scenarios with one simulation softwares. So I see the synthetic data is a one solution where to say that our system works perfectly with all the scenarios. So here are the few things that I listed for the room today to carry out. One is the environmental factors that dominates the DMS sensors, not the algorithms. Algorithms are proven and they are much stable. That what the things that fails is the environmental factors. And the second one is the thing that governs every perception in this DMS is the irradiance that is on driver phase, which is about 0.5 to 2.5 nanowatt per square centimeter. This is the one that governs DMS systems. And third one is the regulatory pressure. Because this is not a future at all, regulatory pressure is current, and as we see, in order to get the Euro NCAP 5-star rating, there is continuous eye and head tracking is mandatory. So that drives the sales for the cars. And fourth one, no single sensors wins this race, and the fusion is the ultimate solution. And the fifth one, and the very important one is, when DMS detects the alcohol impairment from a micro eye yield movements, a 15% irradiance or 15% change in irradiance is a life-threatening problem. It is just not just an compliance failure, or it's just not in system behavior. It's a life-threatening. Yeah, here I have listed few questions for the room. So for the brainstorming, you can think of this, and please feel free to connect me on LinkedIn. Thank you very much. Any questions, please?
Where do you think this will go? Like, where do you think the eye tracking or the sensing that you have talked about will be in the next 1 or 2 years?
As we see, our previous Smart Eye people already well explained it. It's a very impressive presentation. Thank you. Yeah, that is very critical, and every system, every car is going to have it, and not only with respect to the sales, or else when someone is trying to push the market to get the 5-star rating. So that need to be have. So if they are not get a 5-star rating because the Euro NCAP regulations to get the 5-star rating, the continuous eye and head tracking is mandatory. So that is what the 5-star rating which drives the sales. Because when I was buying my last car, I was just going through the NCAP NATSA website, and I was seeing which car got the 5-star rating and what was there they will list what are the failure cases also. That was my based on that research I bought my car.
Oh, thank you. Very insightful presentation. Thank you so much.
Thank you.
Hello. I have a very strong interest in top module, and then sensor future for InCabin application. I love the idea. So, in regards to depth sensing, then so NCAP is now it's mandating more a requirement. And do you also see that something similar will happen in the US as well? And then that's my first question. My second question is, then the tier module perspective. So right now the adoption rate is quite low, but going forward, I guess the adoption rate is going to go up. So what is your estimation in terms of the kind of rapid adoption rate for top module?
Yes, for the first one, yes, it's going to roll over very soon. Yeah, it's not in future. It is coming. It's already in place actually, and there are already companies which are in the at least as per projection, there are so many OEMs coming up with systems. And when if I go to any of the retail car showrooms, you can see they are already presenting it. It's already there actually. Can you help me with the second question, please? It's already there. It's no more in future because already our OEMs are rolling out with DMS systems.
Okay, thank you.
Hi, Kyle Trout from Mitsubishi Electric. We've had discussions in the past about mandating requirements for technology are more focused on outputs and not as much on sensors anymore. That kind of drives the OEM to want to keep the cost as low as possible while still meeting the purposes of the requirement. How do you see that playing out with your opinion about the requirement for all of these sensors to have an effective system while the OEMs are trying to push down cost in packaging space?
Here, see, when we come to sensor fusion, it's all the combination. And behind the scenes, how the algorithms, meaning that when I have the NIR emitter and the T-wave sensor, for example, some might have then very good algorithms, very good behind the scenes algorithms which can make this perception easier. And I believe it's behind the scenes of the background algorithms, which has a scope of continuous improvement. One solution, meaning that with respect to sensors, yes, there is no cost may not be brought it down, whereas with respect to algorithms, yes, it might be possible. And one of the another cases where the OEMs can bring the cost down is validation aspect. So instead of spending months of time to cover all the seasons or all the cases, all the corner cases in order to prove that system is working or to get certifications, a synthetic data might help to prove all the scenarios and to save some cost there.
So what is the most overlooked environmental factor that in your mind that causes a failure?
Most overlooked failure cause. For me, it is about the lighting. Yeah, for me, I see systems may not be tested for all the lighting scenarios, and which is during when I was preparing this this presentation, that's what I learned actually. So that is the most overlooked, but at the simple one.
Natural light, or
Right.
All right, thank you.
Sure.
Anybody else? All right. Thank you for the presentation. That was really interesting, and
Thanks, everyone.
appreciate
Thank
your
you.
time.